Okay, I gave you the memos for A, B, C, and E, am I right? Are you all fine with everything there? So now, I said on the group yesterday, if you did number 1 for today, then it's okay. We'll go through it, and then we need to finish with 2 and 3 today. Okay. But you all need to be able to understand this and do this very well. Because we're finishing up, we're going to do our last trigonometric activity, and then we are going to move on to analytical geometry. Alright, so the first one we're at is D. Okay? Now remember, there are different ways that you can write this and you can still get to the correct answer. But I think something that's important here is when you look at this, remember we said there are things that you can do that's algebraic and there are things that you can do that's trigonometric. Right. So algebraically we can't do anything. Trigonometric, I see a function. I see that one right there. You all see. Tan I can rewrite as sin over cos. But there's just one trick, and that is just the way that we would write it. We wouldn't really write it as a fraction inside of a fraction. We would combine the two fractions. So think about tan. Tan has a numerator of sin, and it has a denominator of cos. Keep sin the numerator, keep cos the denominator. Don't make another fraction. The reason we can do this is because it's one term. So in that one term, all the denominators will be the same denominators. All the numerators will be the same numerator. Do you understand what I'm saying? And now it's very easy for us to see the cos and the cos cancel out and the sin cancel out to get an answer of 1. And then your left side is equal to your right side. Do you understand, grade 11s? Yes, that's what I'm saying. You are complicating it. Because then you would have sin over cos times cos divided by sin. And then you guys tend to make the mistake. Okay. So you can still get to the right answer. You are just complicating the question. Right, next up was sin squared theta plus sin squared theta times tan squared theta. You have to prove that it's equal to tan squared theta. Now, once again, more than one way of doing it. Is there someone who can see a step that I can take? Any step. Anything that I can do right here. No one. Did you guys leave the sums open? Victor? What can I do with tan? Okay. Victor says I can take the trigonometric root and change the tan to sin over cos. Well done. Do you see what that looks like? Okay. Now, if you take that root, you will now have two fractions. You see that? You'll have to make this one a fraction as well. Then get your common denominator, and remember we say we multiply at the top what this one needs at the bottom. So I multiply the sin squared with cos squared as well. That's where that one came from. That one doesn't need anything, so I multiply the two with each other. Then it looks like this. So at this stage I can't do anything more trigonometric. I've done the fraction, simplified it as far as I can. But there is something algebraic that I can do. And that is to take out something in common at the numerator. So when I take out something in common, that will be the sin squared. And I'll be left with cos squared plus sin squared, which is 1. And then sin over cos is tan squared. And then the left side is equal to the right hand side. Is there someone who started with a different step instead of changing tan from sin to cos? Yes, Moana, what did you do? Okay, do you hear what she's saying? She took out something in common. So just look a few steps afterwards. Did you also change tan to sin over cos eventually? So do you hear both in both of them? You take out something in common, you change tan to sin over cos. With the first one, we changed tan to sin over cos, but later on, we took out something in common. So we do the same things. But sometimes starting with the one thing, we end up getting something that looks a bit simpler. That's easier to understand, but there's not a specific right or a wrong way. So just for this specific sum, I'm also going to show you the other method. I'm not going to do it with all of them, okay? So if you took out something in common here, this is what it would look like. I take out the sin squared theta, then I'd have 1 plus sin squared theta over cos squared theta. So with Victor's method, we started trigonometrically. With Moana, we're starting algebraically. If you do start algebraically, don't go forward and backwards. Don't take out the sin and then you multiply it back in. Okay. If you've taken out the sin, now you must move on from there. Sometimes you take it out and you multiply it back in. And you feel like you've done something. Once you've done this, you can change the tan to sin over cos. So I've done the algebraic, I've done the trigonometric. Do you see also with this method there are two fractions? You need to get the common denominator. The same thing we did with the first one. When I have the common denominator, I just multiply the numerator with what the denominator needs. Then do you see there at the top? It's 1. Same identity. And then I've got sin squared times 1 over cos squared, which is tan squared. And then the left side is equal to the right side. It's just freezing. It will move now. That. You understand? Everyone? Can we move on to G? Okay, at G, I've got cos theta equal to 1 plus tan theta. Now, please remember, we didn't say it now with the previous ones. You only write down that answer once, and then you leave it up there. It's just a hint to try to tell you in which direction you should go. If I look at this answer here, I see that I've got two values, two terms in my answer. Where this one, it's one term. Because when I look at this one, I also see that there are two things that I can do right now. I can either use the distributive law, or I can use tan as sin over cos. Two steps, different steps that I can start with. Okay. Because I see that is two terms, I know that eventually I'm going to have to multiply this thing in to get it separated. Because remember, when you take out something common, you make it one. When you use the distributive law, you make it multiple terms again. So I went and I multiplied it in. Cos times 1 is cos. Cos times tan is cos tan. Then I changed tan to sin over cos. My cos cancels out, and I've got cos plus sin. And that's the left side equal to the right side. Okay, H was quite a tricky one. Because there are many things, many options, many routes that I can take that's not necessarily the correct ones. So once again, you need to look at the answer to help you decide what to do. Because if I look at the numerator, 1 minus cos squared theta, I think many of us started to change it to sin squared theta. Did you do that? Did anyone change it to sin squared theta? Not. Okay, normally that's what you would do first. But the reason you'd know not to do it now is when you look at the answer. I want it 1 minus cos. So I want it in two terms and I want it in terms of cos. So I can either leave it like that for now, or I can change it to the other option. Do you guys remember the other option? The difference of two squares. Then it's 1 minus cos, 1 plus cos. So I actually did the denominator first. And then I chose what to do with the numerator. But obviously you can't see that now because everything is written down. But you understand what I mean. Okay. But I first went to take a look at this one. I know the options. It's there. I don't have to think about it. I can choose what I want. When I look at the bottom, I see that there are 3 terms. And that the first one has got a square. And that tells me to look for a quadratic trinomial. So if I were to factorize this, I would make my 2 brackets, cos, and then factors of 1 that give me 2 when I add them. 1 and 1. And that would give me those 2 brackets. Now after I saw this, I knew that I had to use the difference of 2 squares at the top. And once you do that, you can cancel out. And remember, cos theta plus 1 is the same as 1 plus cos theta. There's no difference. And then the left side is equal to the right hand side. But I factorized it. So it's like x squared plus 2x plus 1. Like a quadratic trinomial that you make the 2 brackets. Okay. Right. If you look at this sum, is there anything algebraic like factorizing? Can I factorize anything there? No, I can't take out something common. It's not the difference of 2 squares anywhere. There's not a quadratic trinomial. Is there a trigonometric function in there? Is there a cos squared, a sin squared, or a tan in any form? No. Remember, it must have the square. So that's not a trig function. So can you see that there's nothing algebraic and nothing trigonometric that you can do? But what we do have, the third option, are 2 very big fractions. And if I've got fractions, that means I've got something to do. Because I can make the denominators the same. Once the denominators are the same, what I do at the bottom, I do at the top, and then I see what I can simplify towards. Do you understand? Those are the 3 things. It's only 3 things that can happen that you can start with. And it's pretty obvious when it's a fraction. Right, so I make the denominator the same, 1 minus cos, 1 plus cos. This one needs a 1 plus cos, so I multiply it at the top. This one needs a 1 minus cos, so I multiply it at the top. Now what made this one very easy is that there is a plus. Now I want to say this when we're going to do the next question. If it wasn't a plus, if it was a minus, you would have to put the next part in brackets. Do you know that? Okay, if it was a minus, that would be in brackets because you must subtract that whole thing, not just the 1. You must subtract 1 minus cos. So you're going to see at number 2a, if you haven't tried it yet, that is the big catch. If ever you have a bracket being, or 2 terms being subtracted, it must be in brackets. But in this case, it's a plus. So you don't have to worry about it now. What is 1 plus 1? 2. What is cos minus cos? So I've only got a 2 there at the top. Easy. Now when I look at the denominator, do you notice something about this? The brackets look the same, but it's only the sign that differs. So it's the difference of two squares. You see? So if I were to multiply that, I would get 1 minus cos squared. Do you agree? Now I'm just going to take a look at the denominator. I want sin squared. Is it good if I get 1 minus cos squared? Why? Because it is an identity, so I can just change the 1 minus cos squared to sin squared. Are you done? Can you please indicate to me who started with number 2, tried it? Only Onele. She's got the heart of the lion. At least she's trying. It's going to pay off. Okay. We still have J. 1 over sin theta plus 1 over tan. 1 plus cos theta over sin 180 minus theta. Okay, this is something that you need to remember. The way you remember that tan is sin over cos, you must remember what is 1 over tan. Do you know? Then it's cos over sin, it's swapped around. Remember, if it was tan, it's actually tan over 1. Now it swaps, so therefore sin over cos also swaps. You must remember, we wrote it down when we wrote down the identities. Now if you know that, then this is very easy. You can just put it in there. Cos over sin. Do you see the denominators are the same? So I can just add the numerators. And then it already looks pretty much like the answer. There's only one thing wrong, and that thing is in the answer. That 180 minus theta is not in its smallest form. It's not a reference angle. Now, the reason I want you to look very carefully is if something like this happens. If you want to also work on the right-hand side, then you finish with the left-hand side. And you stop. You don't go on that side. You stop there. Then you can write right side if you want to. The right side is not necessary, but you must start where you stopped. This one. Okay, but then on the right hand side. Does it make sense? It seems like you're frowning. Now I'm just saying 180 minus is the second quadrant. In the second quadrant, sin is positive, so it's just sin theta, and then I see that the right hand side is equal to the left hand side. So I just want you to notice, if you were to make a change in the right hand side, it must be separate from things that you are doing on the left hand side. Okay, I want you to do number 2A with me. Maybe you've got some more knowledge now that you didn't have over the weekend. So remember what I said? There are 3 things that we can start with. Algebraic, taking or doing some sort of factorizing. Trigonometric with an identity. Or fractions. One of those 3. Who wants to take a wild guess what that one is going to be? Is there a trig function in there? Is there a trigonometric? Remember, you don't look at the right hand side. The right hand side is this one simplified. You just look at this one. Is there a trigonometric function? Where? Where? Is 1 minus sin a trig function? When is it a trig function? When it's sin squared. So is there a trig function? No. Is there a trig function? No. Okay, so you can't start there. Second, is there any form of factorization happening there? No. If there was factorization, there would be some sort of a square. Okay? So there's no factorization. Or I would look if there's something I can't take out in common. But there isn't anything. So what's the third option? The what? Fractions. Can you see the big, very, very big fractions waving at you? This side and that side. So that's where we start. How do we add or subtract fractions? Common denominator. So I just write them together, ne? In a bracket, its own brackets like that. 1 minus sin x, 1 plus sin x. Okay, what do I do next when my denominators are the same? What you do at the bottom, you do at the top. So what must I multiply this one with? 1 plus sin x. What must I multiply this one with? Do you see there is a trap? What is the trap? The minus. What did I just say to you? You put it in brackets. So then it looks like this. Okay, and now we're going to multiply the minus in. Okay, but I see I skipped that step. 1 minus 1 will be, 1 minus 1 is 0. Sin minus minus sin becomes a plus, then it's 2 sin x. And at the bottom, difference of two squares. Good. 1 minus 1 minus sin squared, yes. Now look at the answer. Am I close? I need a cos at the bottom. At this stage it still looks a bit far away. But I want to show you what happens. Please see that you cannot cancel that sin with this sin because of the two terms. But I can use a trig function to make that one cos squared. And this is a trick. This was actually the reason why I wanted to do it with you in class. And it's because of the following thing that happens. Please look here. When it says 2 sin x, that actually meant that you had sin x plus sin x. That's how you get 2 sin x. When you've got cos squared x, that means cos times cos. Does that make sense? So what happens is that this sin that I highlighted here is pulling this cos x in the denominator up towards it. So what is sin over cos? And that's why the two of them become the tan, and then only one cos remains at the bottom. That's a bit tricky, but once if you see it once and you understand it, you've got it. I'm going to show it to you now again. I just want a page back. It's the same thing that happened here. Remember, we said tan is sin over cos. Now you've got sin over cos, and it pulls up the cos to become a tan. Do you understand? Okay? If you're done with it, I want to give you not too long. 5 minutes to do B. Alright, I will show you what I did here at the bottom. I just showed the Afrikaans clause. So 2 sin x is just 2 sin x, where sin squared theta, sin squared theta. That's what it is. So that one cancels with that one. That's why if you would cancel that, it's 2 over sin x. So this is not part of the sum. Do you understand? And if you've got sin squared x over sin x, then that sin cancels with that one, and one of the sins remain. So it can only remain if it had an exponent. If it was a square or a whatever. Okay, B. You can open your textbooks. It's almost exactly the same as number A, but there's a little bit more multiplication happening, so that makes it a bit more difficult. So I want you to try it by yourself. 5 minutes. Are you done writing here? On the board? Not yet. You're done. No, I'm just asking, are you done copying from my board? It's actually. Okay, just be careful. It's all the same except you've got more multiplication, but there's also a negative there. Okay, let's do it. Did you see what was shouting at you where you have to start? What is it? Fraction. So you get your common denominator, you just put them together, and then what this denominator needs you multiply with at the top, and what this denominator needs you multiply with at the top. Do you agree with that? So here I have 1 plus sin. I'm going to multiply it with 1 plus sin. Then you write the minus and then you put it in brackets. 1 minus sin. This one needs a 1 minus sin. Do you all understand up to there? Did you do it correct? Now it's just algebra, doing the correct simplification. So when I've got two brackets that multiply that look the same, it's the first one times itself, the first one times the second one times 2, and then the second time 1 times itself. Same with this one, but you see I'm leaving that negative. And I'm first simplifying the multiplication I have here. So it's this one times itself, this one times 2, and this one times itself. And then I multiply the negative into the bracket in the last final step. I also multiplied those two at the bottom because I saw that once again I need a cos in the denominator. So I changed it to 1 minus sin squared. Can we finish it? Do you understand everything that happened there? 1 minus 1, it's gone. 2 sin plus 2 sin, 4 sins. Sin square minus sin square, 0, it's gone. Okay, so at the top I have 4 sin square, 4 sin x. And at the bottom, I have 1 minus sin squared x, but I want it to be cos. So I'm going to change it with the identity. And now do you see we're going to have that same trick as we had at number 2a. That sin takes up one of the cos for it to become tan. And the other one remains. Left side equal to right side. You can quickly write down number 3a as well when you're done, and then I'm going to do it with you. Okay, who wants to try to guess and tell me what's going to be our start? Fractions. Can you all see that? Okay. So, how do I start the fractions? Make the denominators the same. So I just stick them to each other. So I would have sin bracket 1 plus cos theta at the bottom. Do you agree with that? You just stick them together. Okay. What does this denominator need? 1 plus cos theta. Do you see what's going to happen? I'm going to have 1 plus cos theta times 1 plus cos theta. It's a perfect square. What does this denominator need? So I'm going to have sin squared times sin squared. Is there anything dangerous? No, there's not a minus. Ne? So you just multiply them and then it looks like that. Okay, how do I multiply two brackets that are the same? First one times itself, the first one times the second one times 2, and then the last one times itself. And then it looks like this, 1 plus 2 cos plus cos squared. And then sin times sin is just sin squared. Now this denominator, I know that I can multiply it in. Do you agree with me? But that's not very difficult, no? So I would rather leave it as it is. Let's just see how this thing works out. To multiply it back in is easy. But I see that my answer only has a sin. So the moment that I multiply this one in, I can't cancel anything out. So that would be a problem. So I'm just going to leave it as it is there. Alright, now I've done everything I can with the fractions. I've simplified it as far as I could. There's nothing algebraic that I can do like a quadratic trinomial, the difference of two squares. Is there something trigonometric? What? Do you see it hiding there? What is cos squared plus sin squared? It's 1. And then it's 1 plus 1. That's why I made it 2. 1 plus 1 is 2 plus 2 cos. Now I want you to look at the answer. Look at what we have and look at the answer. And tell me, what do you think we must do? You can also look at your denominator. Look for something trigonometric, look for something algebraic, look for something fraction. Tell me? Very good. She says maybe we can take out the common 2. Because you see, I can't cancel anything because it's 2 terms at the top. I need to make it 1. And the way I do that, let me finish, is to take out the 2 in common. And then it looks like that. And then I can cancel it. Okay, so there's only a 3b and a 3c left, but I don't even want you to do number 3c because that's so stupid, that's never coming out. Okay, but I want you to try for tomorrow. I want you to do number 3b. So you see I've got some fractions there. I see a trigonometric function there. And I also see an algebraic something that can happen. You can do all three. You're just going to have to try to figure out which one will be the easiest. Okay. So you do that one. And then at this stage we are one period behind the Afrikaans class because they finished number 2 and 3 for today. Okay, so we only mark today. So let's see how it goes tomorrow, if we can quickly do one or two examples of the last work. And then I'll give you one or two of them to do. Then we'll start with analytical geometry, okay?